Today, let's talk about basic operators in Julia. Operators are symbols that we can use to perform, for example, a basic mathematical operation in Julia. The most basic ones are numeric operators, and they include all the operators that we are used to when computing something with a calculator, for example. So for example, we have the plus operator that we can use to add two numbers together. We have also the minus sign to subtract a number from another. We have also the star for the multiplication and the slash for the division. We can also use the division sign to perform an integer division on a number. Or you can get the remainder of the division using the percent sign, which is called the modulo. For example, we can know if a number is odd or even using the modulo. So for example, 1 modulo 2 is 1, so it's odd. But 2 modulo 2 is 0, and 4 modulo 2 is also 0, which means all odd numbers will return 1 and all even numbers will return 0. You can also raise a number to any power using the caret. So for example, 2 to the power of 4 is written like this. There are also some programmatic shorthands to update the value of a given variable. So for example, if we have a variable called var, which is equal to 1, what we usually do to increment the variable by 1 is to write the variable like this and add 1 to the variable. But what we can do instead is just this shorthand plus equal, and it will increment our variable by 1 here, or by 2 here, for example, to return 3. And the same process exists for the minus sign, the multiplication sign, and the division sign. There are also some different kinds of operators in Julia. These operators are called comparison operators because they are used to compare two values between each other. For example, if we want to compare if 2 is greater than 1, we would use this sign. Similarly, if we want to know if 2 is greater or equal to 1, we will use this sign. The opposite is done using this sign and this sign, inferior or equal. And to test for equality, we just use two equal signs. So for example, 2 equals 1 is false. And using two equal signs is mandatory because if you use just one sign, it means assigning a value to a variable in Julia. And obviously, this is not what we want to do here. We just want to compare two variables, or in this case, two numbers. And what happens if I try to remove one equal sign is an assignment error because we cannot assign a number to one another. Similarly, we can test for the inequality between two numbers or two variables. And this is done using the exclamation mark followed by the equal sign. I think you noticed already that comparison operators always return either true or false. So for example here 2 is different than 1. This is true. But 2 is equal to 1, so it returns false. The true and false values are called booleans. And booleans have their own operators too. So for example we can use the exclamation mark to negate a value of a boolean, meaning we want to get the opposite of its value. So for example if we negate false we get true. If we negate true we get false. So for example, this comparison 2 is greater than 1 is exactly the same as this comparison 2 is lower or equal to 1 but negated. We also have the logical AND and the logical OR in Julia, and this is done using twice this symbol or twice this one. And what the logical AND do is comparing the value on the left hand side and the right hand side, and if both are true it returns true, and if one of them is false it returns false. And what the logical OR does is comparing the two values also, but it returns true as soon as one of the two values are true, and false only if the two of them are false. So if we have two true values like this, it returns true also. And keep in mind that in your code you'll almost never use true or false as is. You'll use variables instead that can change depending on the state of other variables. For example, in this code snippet we have a that is equal to 1 and b that is equal to 2, and we test whether a is lower than 3 and b is lower than 3 too. And the first statement is true and the second statement is true. We use here the logical AND, so true and true returns true. So C is equal to true. And we can use this as a trick to conditionally execute some code. What I didn't say is that Julia evaluates the statements sequentially. And for example, if we get a false value here, no need to evaluate this one because everything will return false either way. And we can use this as a trick to conditionally execute some code. So for example, here we test whether A is equal to 1 or not. And if it is equal to 1, the second part is executed. So here our Pluto Notebook returns A is equal to 1 because it is the case. But if I change the value, it will return false. And we can use the same system with the logical OR. Here, this part is only executed if this part is not true. Because if the first part is true, then the whole expression returns true. Just because there is no need for Julia to execute this statement. And you have to note that all operators only apply at one value at a time. But there is a simple way to vectorize our operators along, for example, arrays. So let's take a little array for the example, avec, which is equal to 1, 2, and 3. So for example, if we want to add 2 to all the values in our vector, a naive approach would be to add 2 like this, use the plus operator like this. But it will return a no method matching plus vector and int64. To avoid this method error, what we can do is use broadcasting. And to do so, you just have to add a dot before your operator. This way, Julia knows that it has to perform the operation sequentially on each element of the vector. There are also other ways, such as for loops and array comprehension, to apply an operation over different values, but we will see this in another video. And that's it for today. And just remember that this video is part of a playlist, so you can follow them in order using this playlist. Thank you for watching and see you next time.